Good morning, everybody. We are going to talk about perception today. This is in a continuation from our sensation unit. And in this uh, video, we're going to talk about top-down processing and perception basics and a little bit about Gestalt psychology. You should have your notes out and be following along. Don't forget to stop, rewind if necessary, and you want to check out the end slides. We're going to talk about some review questions for you so you can quiz yourself a little bit. Okay, so let's get started. We're going to first talk about perceptual organization. And perceptual organization refers to how we select, organize, and interpret incoming information from our senses, our bottom-up information, so we can make something meaningful and useful to us in adapting to our environment. So the first task, and we have several tendencies when we are using our top-down processing, we first must have to perceive an object as distinct from its background and meaningful somehow. And later on we'll talk about how we detect distance and motion. So as you look at this image here, if I said quack quack to some of you, you might be able to see a duck, but if I mention the word cottontail, some of you may be able to see the bunny, but typically we see one of those as distinct, and if we have meaningfulness in our schemas, if we understand what that image might be, we'll have a clearer image and perception of those things. So as you look at this object here, it might not be as clear, distinct, or meaningful as the previous image. And we're going to talk a little bit about visual form perception. And one of the first tasks we have to do when we're using our vision for sighted persons is to separate figure from ground. So our first task, we have to pull a figure or some type of familiar, meaningful object out of a lot of stimuli coming in or the background. And as you look at this object here, some of you may immediately see a figure in amongst the background noise. Some of you may not, however. The second task, after we pull a figure out, is grouping simple forms together. We have to find patterns in the visual field. This occurs in our brain, in our visual cortex, as images come from our senses, vision especially. The perception occurs, remember, when we're selecting information, and then we organize the form, and then we interpret it somehow meaningfully. And when we can't do that, it's confusing. So if you can't do that in this image here, you may be having some perceptual problems because you can't pull out a figure and compare it to something you already know. So think about top-down processing here, and this occurs moment by moment. Many times each moment we are processing our perception. And I'm going to give you another figure ground example here. If you notice this image, some of you may notice this image as chess pieces. Others of you may notice it as outlines of people facing each other. So we have chess images here, big, large chess images here. Or in between, you can see this person face here and this face here are looking at each other. So depending on your expectations, for example, you may or you may not see those images, but you probably only see one and not both at the same time. Let's get back to our slide projector here. So this demonstrates our conscious perception is selective, and the image we just saw with the chess pieces was known as a reversible figure. And that means we can see maybe 2 or even 3 different images, but we typically only see one at a time because of selective attention. And you remember that from our previous unit. And it also shows we only focus on a really small amount of information coming in from our eyes or other senses at a time. And one term you want to be able to identify is something called visual capture. This refers to our visual perception for sighted people dominating other senses. For example, if you are at a movie theater and you see somebody talking on the screen, you perceive the voice, the sound is coming from that mouth on the screen, even though the screen doesn't have any speakers, and the speakers are out on the side of the screen. However, your vision overwhelms hearing and will make you perceive that the voice is coming from where it should be, which should be the mouth on a person. So visual capture is an example of how one sense can dominate another. And before we leave this slide, I'd like you to, for those of you who aren't quite sure what this image is, since we are in the state of Wisconsin, and most of you probably have had some cheese or drank some milk, or I said the words moo moo, can you see the image of the cow's face amongst the background? So we've got the ears here, the eyes here, the nose coming down, the wet nose, and the snout here in the head. So that would be, hopefully you can detect a figure from the background now. So sometimes it takes additional information. So at any moment, our conscious awareness, whatever we're focused on, really has all of our attention. And remember, that's called selective attention. And we may have mentioned cocktail party effect before, our ability to focus on one voice among many in a classroom or at a party. And some of you have probably seen the video of people passing around a basketball, people in white shirts passing a basketball to other people in white shirts, and then people in black shirts passing around a basketball to people in other black shirts. And if you focus on the white shirts, people in the white shirts passing a ball, you may not notice a gorilla walk right through the middle of both of them. Again, this is an example of the selective attention. I'm going to show you another short video here that you can take a look at and see if you can also follow the basketball passes. That certainly demonstrates pulling a figure from a background, the first task in perception. And sometimes that figure I've seen called a pop-out stimulus, where we may have noticed a gorilla coming in and a player leaving the background, but a lot of us didn't notice the curtain changing color, which again refers to inattention blindness, which we talked about a little bit before. And remember from our previous information in our sensation basics video and talking about it in class, that unattended stimuli can have subtle effects, and those effects are called subliminal effects. And an example would be if we subliminally flash the word river or bank on a screen and then ask somebody to write a sentence about the statement, "We stood by the bank," how would that be interpreted? Depending on what word you saw ahead of time. Subliminally, you may draw a picture of a slow meandering river or somebody standing in front of a bank at an ATM machine, for example. So inattention blindness does occur, but those unnoticed stimuli might have a subtle fleeting effect on our perception. So let's talk a little bit about form perception and Gestalt psychology here. Gestalt psychology is the study of how people integrate and organize perceptual information, basically information they perceive, things we see, hear, etc., into meaningful wholes. These were the Gestalt psychologists in Germany at the turn of the 20th century, early 19-teens. For example, what can you tell me about these symbols in blue? And you might recognize this as a face instead of simply symbols following each other. Due to your top-down processing and your expectations, your perceptual awareness might organize that into a whole of a face or a character of a face, as opposed to just seeing the 4 or 5 symbols that are in existence there. So the whole would be greater than the sum of its parts, and that is Gestalt psychology. So Gestaltists do have or have identified grouping rules that your brain uses to organize and create form out of pieces. And that's where the statement, the whole is greater than the sum of its parts, comes from. For example, here in this image, you might be able to perceive a cube as opposed to many intersecting lines on a flat surface. So if you could see a three-dimensional cube, that whole is greater than certainly the intersecting lines that are drawn on that screen. So let's take a look at the grouping rules. The most important grouping rule is called the law of Pragnanz, and this basically refers to the tendency for a brain to organize information into its simplest form and not really super complex forms. For example, on the right, we probably are noticing a square and a triangle intersecting each other as opposed to many different lines. An incomplete square, a mini triangle inside a bigger triangle. We probably perceive two shapes, and the law of Pragnanz would explain why that happens. Proximity rules, we tend to group nearby figures together and perceive it as one unit. So it's likely in this image we probably see 4 columns instead of 8 separate lines because the lines that are closer together are perceived as one unit and separate from the others, as opposed to seeing these 2 lines belonging as a group. That's proximity. Similarity, again, you're probably seeing a pattern. We tend to group things into wholes if they are similar in some way to each other. So in this example, most people see rows of circles and X's as opposed to columns, simply because we group these circles as belonging together as a whole, and these X's belonging together as a whole. Closure is the most impressive grouping rule for me. Closure demonstrates how we fill in gaps of an incomplete figure to create a whole figure that's familiar to us. And although this is a little blurry, you might be able to, this is an impressive one to me, see a sphere in a flat 2-dimensional image here and very crisp circular lines, and see that as a 3-dimensional sphere, or see a white triangle here, even though there isn't one. And that's impressive because your perceptual top-down processing will make this white triangle pop out as brighter than the background. But if you take your finger and cover up one of these little Pac-Man symbols, you'll notice that we lose the brightness. And here you probably see the Loch Ness Monster and not just 3 separate shapes. That's closure. And there's a couple more. Connectedness means we tend to perceive lines and other areas as a single unit, as if linked somehow, even though there are interrupting lines in our original. Continuity, which also means good continuation. We prefer smooth, continuous patterns to discontinuous ones. So we may see waves and circles and arcs in incomplete objects as well. And common fate, objects that are moving together in the same direction are perceived as being together. Geons refers to the simple shapes that, when combined, make up objects or whole objects. So our brain has this visual encyclopedia of geons, which are simple 3-dimensional shapes that can be organized together. So this arc can be organized together with this block, and we perceive it as a suitcase, for example, or this arc, and a cylinder might be perceived as a mug, and so forth. I'm going to show you a few examples of this now, and then we'll stop the video. It's getting a little long-winded here, but Gary Fisk grouping rules. Let's take a look here. So the laws of Gestalt. So let's look at some examples here. And remember, Gestalt laws of form perception describe how people see groups and wholes in visual information and not just simple individual parts. An example, a classic example of here is we might see 2 faces looking at each other, or we might see a vase or a chalice in the middle. Whatever you see demonstrates the first task, which is separating figure from ground. And it's difficult to see both simultaneously, although this is a pretty simple object, you probably can. But We typically see one or the other and not both. An example here would be, if you think about this, what law would demonstrate that we see squares and triangles and circles and diamonds? That would be the Gestalt law of similarity. The law of similarity means we could also group objects based on color. The law of proximity shows that instead of seeing 6 separate squares here, when they move closer together, we probably see 2 groups of 3 blocks. Very simple diagram, but it demonstrates the law or rule of proximity. This one is very powerful for me, even though I know this is just an illusion. This white triangle, even though there's no lines here, those lines or edges are created in your perceptual field, in your mind, in your visual cortex. This white triangle that isn't there is brighter than the background, even though when we remove those Pac-Man symbols, the image disappears, although you might have an after image there. Closure, very powerful. And then closure also helps us see words in holiday lights, for example. So we might see Gestalt here, see the T and the A and the L and the T, even though there are no connected dots here. Closure helps us see things, see words in lights and so forth. And the law of continuity or good continuation shows us that we tend to see complex images as smooth continuous patterns. So we probably see this smooth continuous line even though it's intersected, or we probably see the right angle lines here even though they're intersected. So we tend to find continuous patterns. And remember, the law of continuity demonstrates, and the law of pragnance really, that we see this as 2 intersecting lines and not as 2 inward pointing arrows, because simpler is easier. And the law of simplicity or the law of pragnance shows us that we probably see 2 separate images here, a square or a block and a circle, and not something like this, which would be a more complex image. So the law of pragnance is at work here. Law of simplicity showing that we tend to group things in their simplest fashion. And lastly, the law of common fate shows that we perceive objects moving in the same direction at the same rate of time as belonging to each other as a group. We're much less likely to see the group like this, even though similarity might be at work here. But common fate probably helped us survive. A long time ago, our ancestors survived in the forest or grasslands of Africa when we saw dark dots moving in the same direction at the same rate. If we saw that as a leopard, we probably survived, as opposed to, oh, what are those dots moving? So that is the end of our Gestalt example. So we're going to lock it up and close it up here, make a conclusion here. So remember, bottom-up processing, you might want to process this, is when we analyze information coming in from our senses, we transduce that information and send it to the brain. Top-down processing combines incoming sensory information and our top-down experiences, schemas, and mental sets, and creates a whole as we organize and interpret that incoming information. So some additional questions for you. So thanks for watching. I know this was a little long, one of our longest videos. Be sure to quiz yourself. Can you identify the first steps of perception? Can you describe the 6 grouping rules? And could you give me 3 examples of visual grouping rules that you can see from your seat or from where you are standing? Thanks again, and we'll talk soon.